Good afternoon. Whose time is this our first DevOps? If this is your first DevOps, raise your hand. Impressive, isn't it? This is my, I think, sixth DevOps. Absolutely one of the best conferences for developers in the world. So welcome for all the people here who are for the first time. So today, I wanted to talk a little bit about the Internet of Things in Java. It's not what you see on the title of this slide. It says a new horizon. And for many of us, the whole notion of the Internet of Things is a new horizon. And I want to explain a little bit about what that means. So, obligatory slide, what this means is, please don't bet your business on anything I'm going to say today. Fair enough? All right. So, typically at any technical conference, such as DevOps, we come here and we immerse ourselves in a lot of technical sessions with the hopes that we're going to walk away with skills and information that we can utilize back in the place of our business to be more functional. That's absolutely the premise of almost any technical conference, right? But sometimes it's important that we actually take a step back and look at some broader pictures beyond what can I do today or learn today and do tomorrow versus what is the landscape in front of me in terms of what's changing such that me as a developer, what do I need to know, why should I know it, and why does it matter? That evolution is happening right now for all of us, whether we know it or not. Whether we're in the enterprise, whether we're a server-side developer, whether we're a client developer, whether we do testing, the world of programming is changing fundamentally for all of us in ways you could not fathom. That's what I want to talk a little bit about. So when I saw these numbers that are being projected behind me, I just could not fathom this data, this information. It's unreal what's happening through both social media and mobility in terms of how we connect with the world and interact with the world around us. So much data is being generated real time. Information we are sharing, information we are gathering. And just think about how much infrastructure it takes to handle this type of load in 60 seconds, in an hour, in a day, in a week. We just take it for granted. It's always on. It's almost as if it's a utility, whether it's a water in your home that you turn on. You know when you turn on that water switch or faucet, water will come out. You know when you turn on your light switch, that light bulb will turn on. Well, at least for most of us. California, we have our brownouts now. But it's there. We just don't think about it. We don't have to. We trust that the infrastructure that allows this to happen is going to handle the things that we want to do. And for me, it's amazing. You know, I have a grandmother who's now, pushing 90 years old, who's sending her grandson a tweet across the world. Never thought that would happen. Just 50 years ago, she didn't even know what a phone was. And yet, now she knows what Twitter is. She knows what Pinterest is. She knows what Instagramming from her grandson is. That is unreal, how fast technology has changed around us and how much it's changing our lives. Fundamentally, what is all of this information we're creating? It's data. It's what we're relying on, right? The sheer volume of data that's created, the various types of data that's created, and at the speed of which that data is created at is changing how we look at the world as developers. Handling the types of loads that I showed previously takes an amazing amount of effort for that to be seamless, for it to always be there. All of this data fundamentally will change how we develop, deploy, and manage applications. And we as developers need to realize that. We need to embrace that. There's a new paradigm that is occurring. And data plays a central part in that. Now, these stats that show the forecast as far as how much data is being created year over year, up through 2015, I can't even fathom. You know, 5 years ago, we thought a gigabyte of information was a lot. Then we talked about terabytes, and then petabytes. What's an exabyte? But that's the reality we will be facing now. That is the information that will be being generated. Now, where's all that coming from? Well, right now, most of us, at least I think all of us do. Let's see. How many of us have one of these in our hands, in our pockets, right? This is how we typically interact with the world, through a cell phone, a smartphone, a tablet, a laptop, through social media. But the reality is, there's a limited number of these in the world. Perhaps you have 2, maybe you have 3 if you're lucky enough, or unlucky enough. But what goes beyond that? Things that can also generate data. It's all of those non-human devices that live beyond this. Now, when I saw these statistics, once we started really reaching the billion forecast level of non-human devices in the world, that's when it started mattering to me. Because as humans, what do we care about? We want to be able to control the environment around us. We want to be able to influence the world around us. We want to make better decisions through more information. That's just an innate thing that we all deal with, whether in our personal lives or in our professional lives. And that extension beyond this device that most of us carry around will allow us to do that. The more connectivity we have with non-human devices that generate information will give us a chance to make better decisions. Again, whether it's personally or professionally. So what does that mean? That means this becomes the ultimate remote control in your life. We have to stop thinking beyond just mobility and think about data utility. How do I utilize this such that I can control the environment around me to make better decisions? And it's not just a connection to things. It's not the notion of things connected to the internet where I'm just pushing or pulling information. It's not about setting my thermostat to a specific temperature level. It's not about programming when the lights in my house will come on. It needs to go beyond that. What we're really talking about is not things connected to the internet, but the Internet of Things, such that devices have a chance to communicate with each other, whether through human interaction or not. It's the ability for these devices to understand and recognize and sense each other and know when they should be connected or sometimes disconnected, when information should be shared and when it shouldn't be shared, and when can I, as a recipient, pull that information and make a decision. But none of that can happen without what? You. Developers make that happen. It's the applications we need to create in this next generation of data that will allow this complexity to be simple. And again, as I say, the environment around us is changing so dramatically that we need to stop thinking of ourselves as a specific type of developer and just realize that we are a Java developer, first and foremost. Now, all of these devices need to become a fabric of devices that know and recognize each other. And that's what I mean about Java. We're at the precipice where this is our new opportunity to win or lose. And Java fundamentally has been at the forefront of being an open standards technology such that it allows ubiquity across devices, whether in the backend in the server or on these new edge non-human devices on the remote edge. And so to better understand the Internet of Things, and some of you perhaps have read about this, seen work within this space, it's good to at least to have a simplified architecture of what I mean by this. So you may have smart, connected, wired, unwired, wireless sensors on one edge that communicate information to some gateway device that then shares that with the backend in its simplest form. This is sort of the architecture of when we talk about the Internet of Things that mostly comes up. But it's a bit wider than that. We talk about the gathering layer. This is the layer where the sensors themselves are pulling information from the environment around them. They might be autonomous, they might be interconnected. But that's the forefront of where data is coming in. That is on the edge, and that's where the starting point begins in this equation. The second layer is sort of the enriching layer, as I define it. What does that mean? The context of when should I be pulling that data off that sensor that's streaming information? How often should it be coming in? And who should it be shared with? Streaming. Streaming is about sending information up as well as down. A lot of these devices on the edge may be in the field for years that you never touch, but you want to have an ability to be able to give it a firmware update or tell it to take a different action than it was originally intended to do. And in the same way, you want that information to be streamed backwards as well. Storage is kind of obvious. In that aggregation of petabytes, exabytes of data, someplace has to be the repository of that. Acquisition, acquiring, and organizing. What that fundamentally means is all of that data that's generated, does it really have any tangible value unless we're applying logic to it, intelligence? And that for me is one of the most important parts in this architecture is it's one thing to gather data and think we can do something with it, but until we apply intelligence, how can we know whether we're making the right decisions or not? And as I said, Java is in a perfect position to address this Internet of Things environment that I'm talking about. Sometimes you have to step back and just realize just how amazing Java has been over the years. We sometimes forget just how much richness Java has provided us. I know I'm humbled by these numbers and this data. It's just taken for granted, but we should reflect on it. In its roots, Java has been addressing the small microenvironment for years. And it aligns perfectly with the Internet of Things opportunity that's in front of us today. However, and there is a however, we need to accelerate, we as Oracle, as the stewards of Java, need to accelerate the advancements of the technology, the platform, the APIs, such that you as a developer have a common set of tools and APIs to utilize in the next generation of Internet of Things applications. Today, if we look at it, we have several implementations. Even in the mobile space, we have CDC, CLDC. It's spaghetti soup for a lot of us. It's too complex, right? If I don't have common APIs and libraries that I can just pull, and whether I'm building a very small application that targets a very small micro footprint of memory, or something more robust, it adds just another complex layer that I need to address. Now, if we look forward, 2014 is going to be a monumental watershed year for Java with the release of Java 8. You'll see more commonality, so you have more common tools and APIs as developers to take advantage of. And if we forecast out beyond Java 8, hopefully it's rendering, there we go. Beyond Java 8, you'll see just much more integration such that the implementations you'll see is a lot less. And what does that mean? It means you get rid of all that spaghetti soup, right? It no longer is about being a client developer, a server developer, a UI developer. It's about being a Java developer fundamentally. And that's what we need to start thinking of ourselves as just as a developer where I have common tools, libraries, APIs that allow me to address that wide swath of space, whether on the microsensor level or on the server level, to start building out these applications in the Internet of Things. So a great starting point is with Java Embedded, of course. And you need to start looking at what are the types of devices I can immediately start utilizing and targeting. Economies of scale has brought down the cost of devices to a level now where it's easier now to start building out these applications. Of course, on the very small end, on the Java card end, where authentication and security is important, that's been there for many years. But when we start talking about systems on chips, microprocessors, you have Java Embedded at your disposal right now to target those. And then as you move up, of course, there's other implementations you can use. But the IoT environment, if any of you are in the embedded space know, It's extremely fragmented. Extremely fragmented, which means being able to target a specific chip is very challenging unless you have a port and implementation on that chipset. And we at Oracle are doing that right now. What you see behind me right now are some of the more popular chipsets where we have specific ports of Java for you to start working out of the box. And if anyone saw any of the labs, perhaps yesterday, or made it down to the Hacker Garden, perhaps you saw the Raspberry Pi. Great starting place to start working with and getting your feet wet in the Internet of Things, because we have a Java implementation for the Raspberry Pi as well. And if this is new to you, it's a great place to actually start. I would recommend you go to youtube.com/Java, and we have a series of screencasts in terms of how to start with Java utilizing the Raspberry Pi. We're actually lucky enough to have one of our lead Java evangelists, Simon Ritter. Where is he? Raise your hand, please stand up. He's created a series of screencasts up on YouTube for you to go and get started on that. Thank you, Simon. Now, the whole notion of Internet of Things, the data gathering, the generation, which industries does this allow ourselves to start targeting? You may say, well, I'm in the finance industry. This really doesn't touch me. Or I'm in insurance, and this really doesn't touch me. There is no industry that the Internet of Things won't touch. Let me give you an example. Banking. ING, for example, is trying to understand how frequently an ATM is utilized with sensors throughout the range of world of ATMs that they have around the world. What kind of uptime does that need? What kind of firmware does they need to continually update and push out? In the hospitality industry, I didn't even fathom that IoT had a meaning there. Think of that little mini bar. How many soda cans are coming in and out of that refrigerator? Where the hotel knows who's consumed what, how often, and start developing a pattern of frequency so they know how much to be acquiring and purchasing at any specific point. That's where that data has value, as long as you apply intelligence to it. But the industries you see here are some of the more common ones where IoT has meaning. Home automation and gateways. Some of you might already have this in your home. I know for those of you in Europe, you're leaps ahead of what we have in the US. Deutsche Telekom is rolling out an entire home automation system such that it's not just about a bit pipe connected to the house where you're serving up entertainment. But that pipe now becomes a channel and conduit to better utilize the homeowner to have more control of his life within his or her home. Industrial automation. How can I be more productive in manufacturing? How can wireless sensors and embedded systems make me more productive in that manufacturing process? Healthcare. I mentioned my grandmother earlier. I would love it such that her diabetic device gives me updates as far as what's her sugar level. Did she receive the correct dosage from the medication she's taking? If her sugar level is out of balance, was her doctor notified of that? Those are things the Internet of Things can do for us. It has meaning. Now, I showed some chips manufacturers where we have specific ports of Java already available. But there's also a range of devices already out there by specific partners and companies that you can already start targeting that you see here as well, right? So it's not about just the application layer of Java on a chip. It's actually making utilization of specific devices that many companies that you see here are actually producing to make it much more of a reality for you. But how does this become more of a reality? Like I said in the introduction, a lot of us come to these events and conferences, and what do? We gravitate to the sessions that are more important to us because we want to be able to take skill sets back to our office to be more productive, or it's an area of interest. Thing is, we need to branch out. Go to areas and talks and sessions and information and have conversations with people perhaps we never thought we would before. Because the Internet of Things, it's here. It is a reality. If there's anything you can take away out of this session specifically, is I ask for you to go to the iotcommunity.org. We have another Java evangelist here. Jim Weaver, where are you? Please stand up. He has set up an entire portal for all of you where it becomes an aggregation point of all things developer-related, Java developer-related, on the Internet of Things, where you can share, learn, contribute, such that it becomes more of your muscle memory where when you go back to your enterprise, you have a better sense of, what do I tell my architect? What do I tell my CEO or CTO? The information is there for you to glean from, but also to contribute towards. Now, it's one thing for me to say a lot about the Internet of Things and sort of hopefully convey to you that it's important. But I think it becomes much more real as if we can actually have someone in this space who's working and actually doing work at the chip level to talk a little bit about the Internet of Things. So with that, I'd like to invite Jose Sanchez from Gemalto, one of our partners who's utilizing Java on their microcontrollers. Jose.
So thanks a lot, Sharat, for giving me the opportunity to talk today. It's really a pleasure to talk to all of you and to be, let's say, talk about one of the specific applications that Sharat just talked about. We call it M2M. Sharat just said Internet of Things. I mean, we mean the same thing. We mean connecting machines, connecting things with people and with enterprises. So for those of you who don't know Gemalto, I mean, maybe some of you know us from the SIM cards. We produce SIM cards, and we have also a range of services. But basically, what I'm going to talk to you about today is about our wireless modules and about how to quick start your M2M application with Java and with our wireless modules. Basically, let's go to the point. We are already shipping since more than 15 years wireless modules to all kinds of industries. So we really, our customers are ranging from, let's say, track and trace device manufacturers to healthcare device manufacturers to let's say, even in the case of this picture, you see how the modules are integrated on the German train system to inform passengers of the current status of the train, and also on some gateway devices. I mean, you name it. Actually, we are shipping millions of modules. And we are leveraging and we are partnering with Oracle to leverage Java on our modules since already more than around 10 years. So what M2M module is basically a modem, but it's not only a modem, and I will come to that later. An M2M module is a piece of hardware that you can connect with an external application processor, or you can use as an application processor to connect to external sensors, actuators, and connect your device to the internet. Cellular modules are in a range of 2G, 3G, 4G technologies. They are available, and they provide basically data voice modem functionality. And additionally, of course, there are some interfaces to interact with sensors like GPIOs, analog to digital converters, sensor SPI and I2C interfaces. Of course, there's always an antenna port to connect your device antenna, and some USB serial ports. So depending on the type of module, you have different interfaces available. So this is really a subsystem which integrates all these kinds of interfaces, also an audio interface to connect to a microphone and speaker on your device. So we really connect these modules, our customers connect these modules to machines, and we felt that was not enough. We needed to add intelligence to those modules. And how do we do it? We basically add Java to them. So we added a Java virtual machine on top of the modules. It's J2ME based, and it allows our customer to basically reduce the cost of the application by eliminating or minimizing the investment in hardware, and not having to add one external microcontroller to the application. So it's really a minimum amount of components that you need to build an M2M application. So that's one example of one of the modules, and this is so far quite far away from the, let's say, developer community, from what we are really talking about here at the DevOps. It's really making things happen, right? So you can't start with such a module. You would need to do your own PCB. You need a big investment in the beginning. So it's really the reason why we have actually created a new type of development board that extends the traditional module and adds interfaces, so you can quick start your application. Basically, this is the concept board, and we have it out there at the booth. The concept board is based on the new generation of 3G modules, which run a Java virtual machine. It's J2ME based. We delivered also with the concept board, you get an SDK where you can just simply start programming your applications on Java. You have a cellular modem and an antenna. You just need a SIM card, and you can attach Arduino type of shields. So we have extended the board in order to make it easy for you to get started and build a prototype. But basically this is available starting already today through our web shop. And yeah, I'll be glad to see you at the booth and explain you a bit more details on the hardware interfaces that and the possibilities to extend the board. So how do you get started? The idea is that you start with a board, getting one of our concept boards. You just need a SIM card. Once you get the SIM card, you get from us so you get the SDK, and you can start programming on your PC, develop. You also get some samples from us. If you go to our developer zone, you will see a range of examples, just Java code, how to send an SMS, how to connect to a remote server, and so on. You're programming on top of an abstraction layer. Basically, you're programming. You don't have to know anything about the modem, the underlying modem, the AT commands. You can use the AT commands, but you don't have to. And basically, you can also debug your application over the on the device using the on-device debugging functionality. In the end, the idea is that you deploy and use this concept board for your prototype at home. But also, if you have an idea, you can scale it up. And how do you scale it up? You start with a concept board. I mean, you might have a business opportunity, business idea, and you show it, you prototype, and very quickly you can move to one of the terminals, which is another M2M device. It is completely ruggedized, and it has the same module. So basically, you just port your code to the terminal, and start shipping in a cost-effective way. And once you are, let's say, growing after a certain time, you can always do your own PCB, your own design, your own box, and use one of our Java modules directly. So it's really a way for you to get started. We believe it's it's the easiest way available today to get your prototype, a connected prototype. Yes. And we are really would be very, very excited to. I'm really excited to start to see how is the reaction, to start sharing our knowledge with you and have you share your ideas with us. That's the only way we can achieve the dream, and this is our goal definitely. So thanks a lot. I mean, you can visit us at the booth, and I will explain you a bit more about the concept board and about our modules and how Java is built on the modules and what you can do with them. Thank you.
So, as I said, this is a new space for a lot of us in this room. And we wanted to leave a little bit of time for you to actually have a bit of Q&A. So we're going to move into a question and answer period, if you have any. I would like to actually ask Simon Ritter and Jim Weaver, two of our Java evangelists at Oracle. Please come up if you can, if you don't mind. I'm putting them on the spot. I love it. All right. So, questions, comments, feedback. This is your chance. You have the experts right here to my right. Or is everyone ready for their coffee break?
Question now.
Question.
What's the minimal footprint for Java ME? We got a mic.
Yep, here. Ooh. Yep.
So the question was, what's the minimal footprint for Java ME? We can squeeze Java ME into less than 1 megabyte in terms of the actual requirements for the actual platform. Obviously, you would need a little bit more memory to run your application, but in terms of the minimal requirement for Java ME as a platform, it's less than 1 megabyte. It's somewhere around 750, 800 kilobytes. So pretty small.
Just raise your hand. Yep.
Right, so the question was Java SE8 embedded, which we've seen on the Raspberry Pi because there's early access of that available. What's the footprint for that? That's more like around, trying to think, it's definitely bigger because it's sort of around 30 megabytes, but it is a full Java SE implementation, so clearly the requirements are higher. One of the things with Java SE8 is that we're introducing the concept of profiles. And so if you are looking at deploying something onto a platform, what you can do is you can use one of the profiles, which reduces the size of the libraries that you actually deploy. And so there are 3 profiles which start at around 10 megabytes in size. And that gives you the basic security manager, class loader, logging, all the things you need to actually get your Java application running. And then depending on what you're doing, then you can use a slightly larger profile. So if you need other capabilities, then you can do that. This is like a stepping stone to the idea of full modularity, which is what we'll be hopefully doing in Java SE9, where you'll be able to select which of the class libraries you want and then be able to package those as part of your application. There is a kind of backdoor way of doing things if you want to deploy something and actually have a smaller sort of implementation, because one of the changes that we're making in Java SE8 is also that you can, if you create an application and you want to strip out the libraries that you don't need, you don't have to stick to one of the profiles. You can actually strip out the libraries you don't need and ship that as your part of your application. But the licensing terms say that in order to do that, the Java virtual machine has to only be used for that one application. So you can make it like a complete application which has JVM, class libraries, and your code. But it has to be like a sealed application. So you can't use the JVM for general purpose applications. So there's various ways that you can reduce the size of the footprint if you're dealing with embedded.
Question at the top.
Do Java ME need some kind of operating system, or it just runs on bare?
Right, so the question is, does Java ME need an operating system? To which the answer is yes, because what we have is a JVM. So the JVM is the virtual machine, and therefore you need to run on some kind of platform. We have done various things in the past, certainly when we were at Sun. We had ideas like there was the Squawk VM. I don't know if anybody remembers the sunspots. Yeah, a couple of people. So the Squawk VM was the idea of a Java ME implementation that did run on the bare metal. So there was no actual operating system underneath it. We did all the sort of like scheduling and stuff like that in the JVM. But we didn't really find that proved to be too popular. Most of the platforms that we're targeting with this kind of thing are all running some kind of embedded OS. So it's easy enough for us to stick on top of that. And because our memory requirements, are not right down at the microcontroller level, the kind of platforms we're working with do have an embedded OS. Does that answer the question?
More questions? I thought I saw one more hand.
No.
Right here.
We are currently doing like an M2M application for the automotive business, and we're prototyping it for the moment with Arduino. What does the Java space has to offer in terms of running on that platform?
That's a very nice lead-in
It's a good
for me.
segue.
That is.
I think that's a great segue.
Yeah, great segue for me. Come to my session later on
right.
today, and I will talk about Java embedded in the automotive space, and what I've done with actually using the Raspberry Pi in a car, and some of the things that you can do with that. So yeah, there'll be a lot of discussion around that in terms of the kinds of things that you can do. So yeah, I would say
There's no liability for them if they replicate what you did to your car, is there?
No, absolutely.
Okay, good.
Ours also caught fire, so it's not.
All right.
But yeah, I mean, we should talk afterwards about that kind of thing.
Okay. I don't think I saw any other hands, but one last time. Any more questions? Okay, thank you for your time today.